And usually, these frequency bands are used in the following way in cellular network. You see the entire space is divided in this idealized picture into many hexagons. Each of these is called a cell. And in the cell, there's an infrastructure called the base station, sometimes called node B in 3G or evolvable E node B in 4G. And then there are also many mobile stations, MS, sometimes called user equipment. And each base station is usually composed of directional antennas pointing to different directions. For example, 3 sectors, each being 120 degrees, with a set of direction antenna pointing towards that direction. And we call the communication from the base station to the mobile station downlink. And from the mobile station to the base station, uplink. And we're just not drawing the other parts of the cellular network. How do we connect these base stations to the rest of the internet? That will be for later lectures. So today we just focus on the air interface. And you may wonder, why do I divide the space into hexagons? That has to do with the way we're using the electromagnetic spectrum. Let's say one big chunk of this overall frequency band is labeled 1, another labeled 2, 3, 4, 5, and so on. If I use the frequency band labeled 1 at this physical location, what happens is that signals would attenuate over distance. Suppose the distance between this base station and this mobile station is d. And the signal attenuation drops over distance, roughly speaking proportional to d to the power minus 2 to d to the power minus 4. Depends on the propagation environment. Now, this sounds like a bad news because your signal gets weaker and weaker over distance. In fact, it is a blessing. Because of this attenuation, I can reuse the same frequency band, labeled 1, at a sufficiently far away distance. Okay, and this is what people call frequency reuse. So I will just tessellate these cells, hexagons, in the space, and then I'll be able to reuse the frequency as long as they are far apart enough from each other. Now, in this case, we see a frequency reuse factor of 7. So this was the essential idea, leveraging the fact that signals attenuate over space to reuse the same frequency band. Now, imagine how inefficient radio communication would be if you cannot reuse the frequency band. Then if you have to cover 100 regions, then you're going to need 100 of these chunks of frequency band. And you soon run out of the spectrum to use. Now let's take a closer look at this resource. The resource is the air, or more precisely, the spectrum. We talked about a licensed spectrum. There are also unlicensed spectrum, which forms the foundation, the media, for Wi-Fi communication. Over there, you do not have to pay anyone to get a right to transmit. As you can imagine, the jamming situation can get quite bad over there. Now, we'll worry about that in Lecture 18 on Wi-Fi. In the air, the signals suffers all kinds of distortion. One is signal attenuation. Okay. The power drops over distance, and that leads to frequency reuse and the foundation of cellular network. Another feature is interference. Okay. Not only you are transmitting in the air, other people are also using the air, and you might collide. Later in Lecture 18, we will draw a detailed picture of what actually happens during collision of packets. Today, suffices to say that if two users transmit at the same slot in time, then their signals will interfere with each other. And the analogy that we'll focus on in today's lecture is a cocktail party analogy. So suppose you are in a cocktail party and you want to talk to your intended recipient. Okay, so Alice wants to talk to Bob. Now there are many other people around you, and they all talk to each other. For example, Chris may talk to Dave. And so happens that you are very close to Chris, and therefore Chris' voice actually becomes interference to you. And then there are other people around the intended recipient, and their communication also interfere with your conversation. So Bob will actually hear a lot of different voices overlapping on top of each other. Now the question is, how can you communicate in such a cocktail party? How can you mitigate and manage the challenge of interference? Now, one strategy that we'll be focusing on in today's lecture is transmit power control, or in the case of cocktail party, volume control. You're going to try to install a protocol of courtesy that says, if you don't need to shout, please don't. And that is the spirit of transmit power control in 3G CDMA network that we'll be talking about momentarily. So keep this cocktail party in mind throughout today's lecture.